zoom out a little bit. We are starting in Gramland today. We are starting right here, Gramland. We are going to travel to Moletown. Because we bring words down to the right, that means that we're dividing by molar mass. Once we're in Moletown, boom, we got to cross the bridge. So we're going to turn into the other element that we're talking about. Once we've crossed that bridge, we've done our mole ratio using coefficients. We're going to travel back to Gramland by multiplying by molar mass because we bring words down to the right. You can't mess up, all right? That's the route. That's what we're doing. So let me put our problem right there. Let me zoom in really far. So if you want to be on the Jamboard, that's cool. If you don't, that's cool too. I have my screen very zoomed in, so you should be able to see it pretty well. And I'll tell you when you should take a screenshot, okay? All right, so what we're going to fill out right here is we're going to be using the theoretical grams of A, and I want to know what is grams of B. Okay, so I put a little question mark there. Okay, so grams of A to grams of B is what we're doing. And just so you know, it matches up with the first question on your little exit ticket today. I think I have hair in my mouth. Hold on again. Okay, we're good. All right, so grams of A to grams of B. Okay, so we're going to start with grams of A, obviously. Right? That's where we're starting. Sorry, we usually circle this and we underline that, right? Okay, so grams of A is what we're starting with. Remember, this is always the given. Okay, so this is the given to you in the problem, right? All right, so then we take our words. We're going to travel those down to the right. So I'm going to take grams of A down to the right. Okay, so remember, we have to get to grams of B. We have to somehow convert over to B. We cannot just put grams of B above it, right? That is not possible, ever, never, 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 okay? It does not make sense ever. Don't do it. So what we have to do is we have to be in the words of the mole, right? We have to be in Moletown. So we're going to travel to Moletown. So we're going to be talking about moles of A. And let me actually change one tiny thing. I meant to do this last period too. We'll do this. Okay. So we're going to be in grams of A. We're going to go to moles of A. All right? All right. So now we're going to talk about what goes into these spots. So when we're doing grams and moles, this is our molar mass. Always molar mass. That comes from your periodic table. Okay? No matter what. How many moles is it always going to be? No matter what. You may remember? With the molar mass. 1, yep, good. Good job. Okay, so 1 mole. I'm going to put a circle around this. That's because it can never be anything but the 1 mole. Remember how I said this is going to be simple because it is always that. No matter what, you're going to have a 1 in that next box. All right? Okay, so now I'm going to bring those words down to the right. Okay, so I brought down moles of A to the right. Down to the right, okay? So now we're going to be talking about moles of B. So I'm going to change over to red. There we go, okay? Moles of A to moles of B. So what you should have noticed was, oh, moles are at the bottom. Boom. We are crossing the bridge. We're doing our mole ratio, okay? This was a conversion. I'm going to label that for us. This is our mole ratio. What goes into the mole ratio every single time? Starts with a C. Yes, I'm reading your mouth. Good job. All right, yes, it is coefficients. Good, okay. So coefficients, all the time, never anything else. The way that you'll know which one goes where is because you bring those words down to the right, okay? So this came from up here. All right, next square, next step. We're gonna bring those words down to the right, right? So now we're at moles of B. Let me write this out real quick so you have to switch colors. Actually, yeah, there we go. So moles of B down here. Okay, so we're in that last step. So we already crossed the bridge. We have to come back to Gramland. So now we're going to finish with the grams of B. Okay, so grams of B. All right, so for this step, what we're looking at is, once again, this is a conversion step. No matter what, we are dealing with a 1 mole. So I'm going to put a circle around that. No matter what, it's always 1 mole. This is always your molar mass. And we get molar mass from your periodic table. Okay? And then when we look at our answer for this, it's going to be, oh, I didn't mean to scroll over that far. Okay. It's always going to be what is left up top, which means you're going to have your answer in grams of B. Okay. All right. So this is an okay spot to take a screenshot if you would like the close-up of it. And then I'm going to zoom out in a second. But big picture here, what I want you guys to see is the change in color here, right? So we have the A kind of uses up these squares right here, okay? The B uses up these. It's always going to be that. So once you're dealing with like hydrogen and oxygen, right? Hydrogen gets these guys, oxygen is all these guys. If you ever try to switch things up and put an extra hydrogen over here, then that's how you know you're doing it wrong. You have to have 3 of the same going in this little L shape and 3 of the same going in this little L shape. Okay, I'm going to zoom out for a second. Okay, it'll still be there because I'm going to use this as our guide for this question. Okay, all right. Oop, where did it go? There it is. Okay, sorry. Okay, so let me scooch this over so that it's in the shot a little bit better. Okay, there we go. So we're going to calculate this. So this is calculate the amount of oxygen produced in the reaction of 69 grams of water. So what we're going to start with is obviously what we've always been doing, which is we circle where we're going, right? We're going to underline where we're starting. So 69 grams of water, okay? All right, I'm going to write out the little balanced equation. We're going to put some coefficients into it real quick, just so it's a little bit bigger on our screen. So H2O is going to decompose. It's a decomposer. Decomposition, there you go, reaction. So we have H2 plus O2. In order to balance it, we're going to go ahead and look here. We have 2 H's, 2 H's. I have 1 O, 2 O's. So that means that I'm going to put a big 2 in front of this. Now I have 4 hydrogens, so I'm going to put a big 2 right here. This is left blank because it's going to be a 1. All right. Now, this is the part that I wanted to bring up. So that other teacher, that 4-minute video, where she starts it off doing, is she has her students do this. She says, she doesn't just make them like underline in the question like I make you guys do. She has them actually write it out, and I think it's such a good idea because now you read it. It says calculate the amount of oxygen in grams. So that means that this is what we're looking for. So tell yourself that, right? You're just going to write it underneath it. Over here, we see that we have 69 grams of water, and so we're going to put 69.0 grams H2O. And that way you have this ready to go, right? Then what she makes them do is she has them look above and she says, okay, now write in your molar masses so that all you're doing is you're getting all the information that you're going to need because you already know we're going to need both of the molar masses, right? According to our little plan over here, we have molar mass here and here. So let's go ahead and look at our periodic table. Let's grab that information. So H2O, so 2 hydrogens and 1 oxygen. When I go to calculate that, I'm going to go ahead and type in 2 times 1.008. I'm going to add that to 15.999. I get 18.1 or 0.015. So I'm going to put 18.015. And then we have this 2 oxygens over here, right? So the little 2 is telling me I have 2 of them. So I have, so I'm going to have 15.999 times 2, 31.998. grams per mole. All right, so now I can actually get into the whole stoichiometry thing, and I have all my numbers. We aren't going to have to search for things, okay? So let's go ahead and run through it. We're going to use this guide. There's no reason to sit here and guess, all right? It'd be great if we had it memorized, but we just learned it, so use it, okay? It's going to be off here on the right-hand side, okay? All right, so we're going to start with what we're given. So the givens are down here, so I'm going to go ahead and say 69.0 grams of water. Okay, so I have that written. I'm going to go ahead and start my little stoichiometry track here. I'm going to bring my words down to the right. So I'm going to bring grams H2O down to the right. Okay, I know that this is my conversion step. This is my conversion step. Okay, so we're going to be going from grams of H2O up to moles of H2O. Okay, so we know that grams of H2O, we need to have our molar mass. We wrote all of our molar masses up here. So H2O was this one, 18.015, right? We got that from the periodic table. Up on top, it is always, always, always that 1. Okay, so we have a 1 right here, the guaranteed 1, right? So molar mass and that guaranteed 1. Okay. We're going to go over to the next little box. We're going to bring our words down to the right. We're not going to guess. We're going to use that to our advantage, right? So we have words coming down to the right. So I'm going to bring moles, H2O. Bam, we already have moles down to the right. So that means that is going to be our mole ratio, our mole bridge, right? So we're in the mole ratio step. So that means we're going to be grabbing coefficients. So we're going to go from moles of water. We're going to switch over to moles of whatever we wanted, which is right here, right? Moles of oxygen. We're going to take our little coefficients from the balanced equation. So for the moles of water, you're grabbing A2. Okay, so these are the coefficients. I forgot to put, oh no, it's up there. Okay, coefficients, right? So 2 of those, and we have 1 oxygen. So we're going to put the 1 right there. Notice I'm not circling that one because that's not a guarantee, right? You have to grab that from the balanced equation. All right, I'm going to bring those words now down to the right. So moles of oxygen comes down to the right. We're going to finish this up. We are going to be converting into grams of oxygen in this step, which tells me this is my little conversion step. Okay, so we had 1 at the beginning, 1 at the end. So looking at this, just like up here, the 1 is now going to be in the lower corner, right? Because 1 mole, no matter what, always that 1. So I'm going to put that in a circle just so I can remember. That's a guarantee. This one up here is going to be our molar mass. So we're going to grab that from what we collected right before we started this. So 31.998. So again, these came from the periodic table. We are ready to type into our calculator and be done. Woo! All right, so we're going to type this in. So I'm going to go across the top. So I have 69.0 times 1 times 1 times 31.998. I'm trying to type with my left hand. This is really funny. All right, so I'm going to push enter. And then we're going to go divide 18.015, divide 2, divide 1, push enter. And now we're left with 61.278. So we're going to look over here. I have 1, 2, 3 digits. So I'm going to go 1, 2, 3. So 61.3. We're going to round that one up, okay? So 61.3 grams oxygen is our final answer, okay? And that's it. So fun stuff. So if you'd like to take a screenshot, this is another good time. That way you have one example. You kind of see everything working together if you want that. Otherwise, you do have access to this Jamboard. So you can, and right when you open it, it's the first slide, okay? So you have everything here. If you want, go ahead and open up your assignment. We'll do the first question together, and I'll leave the last 2 for you.